Questions going once? Yes.
So like, is it like what do we need to know? Like all the angles are like, is it just those two angles?
I didn't say it's a triangle, so there's only two angles. Oh, I see what you mean. No, because it's not a triangle.
Oh.
It's just saying it's two complementary angles. Two complementary angles don't have to make a triangle. So just be careful what the question's asking for. If I would have said it's a triangle, find all of the angles, then you would have to. But then I would have given you three ratios. All right, so that's 37.5 degrees. All right, I'm going to do the lesson, and then I'll go over questions from the homework, because most of it was algebra review, and it's just whether you remember it or not. So we're going to continue on to today's lesson. And today's lesson, you've kind of seen this. We're going to talk about the means extremes property of proportions, which will lead to all of our other properties of proportions. But you've already done the means extremes formula, right? Right. No, you never called it. You never called it the means extremes, but you've used it before in Algebra 1. And you'll see it when we get to it. So, the first and last terms of a proportion are called your extremes, which makes sense because they're the extremes, they're your very ends. So these are your extremes. And so the middle terms are going to be your means. Means and extremes. So if we look at that first one, this A and this D are going to be your extremes. Yeah, spelled right. This B and this C will be our means. So an example of this would be 6 to 9 equals 2 to 3. When they're in fraction form, it's a little harder to see, but our 6 would be our starting out term, and 3 would be the end. So these would be our extremes. And these middle terms, that 2 and that 9, are going to be our means. The means extremes property of proportions. Most of the time, even if it's written like this, I'm going to write it in fraction form because you've done this before. You've done the means extremes formula before. So if I had a proportion, so it's A over C equals, actually let's make it, what would be better? I guess A over B equals C over D. That would be better. The means extremes formula says that the product of the extremes is going to equal the product of the means. So the extremes are A and D. So we're going to have A times D. I'll just put AD. These are my extremes. Is going to equal the multiplication of my means, which are C and D. These are my means. Yes?
Wait, aren't they both you put down A?
Oh, I meant B. Yep. I changed my letters around. I shouldn't change them halfway through. We have A times D equals C times B. Have we seen that before? Or if I have fractions on either side, I just take the top, multiply the bottom of the other one, and this. It is cross-multiplying. That's why cross-multiplying actually originated. So this is actually just cross-product. It is just cross-product multiplication. That's all we're really doing. We just put a new name to it, means extremes, because each math has to come up with their own terms. Geometry is like, no, we're not going to use cross multiplication. We got means and extremes. We'll use that. But it is just cross multiplication. But based upon this, we can rewrite this statement a whole bunch of different ways. Well, 4 to be precise. So if A over B equals C over D, then it is also equivalent to, well, we already did the first one. And that would be A times D equals C times b. So that's one thing that's equivalent to. And I'm going to circle that because we're going to do some work on the next one. So the next one, we're going to start off with the fact that a times d equals b times c. But we started out with b on the bottom. But if you look here, I could divide both sides by c. And then I could divide both sides by d. So in other words, I could take this c and throw it under there. I could take this d and throw it under there. So we are going to also have a over c equals our b over yeah, b over d. No, I did that right. I just want to make sure I got all my letters the same. So what happened here is I actually switched my means. So you can switch the means. So if you ever have a over b equals c over d, that's equivalent to if I flip these two things. The fractions stay equal. So I can flip my means. Our next one is, well, let's start with that a times b, d. AD equals BC once again. This time I'm going to move my A under here. And I'm going to move what do I want to do? I guess we'll use the C. That'll be the easy way to see it. We'll put the C under there. So we are going to have basically B over A equals D over C. Which is just a reciprocal. This is just our reciprocal property. So we could just take these and flip them. And obviously the ratio is going to stay the same, because if this was 2 over 4 and this is 3 over 6, if I flip both of them, it's going to preserve that ratio between them. All right, the very last one. The very last one's a little bit weird. The last one's a little bit weird. We're going to take that A over B, and we are going to say I'm allowed to add B over B to that. Because that's adding 1 to that side. As long as I add 1 to the other side. Because if I add 1 to one side, I have to add it to the other side. But I'm going to add it to this side in the form of D over D. We all agree that I'm just adding 1 to both sides. And it's still balanced. Grace, you look angry at it. I'm just adding 1 to both sides just in the form of B over B and D over D. And remember, this is just a way to rewrite it. So this is probably the oddball one. So we have A plus B over B on this side equals C plus D over D on this side. So this is the other common way to rewrite it. This is just adding the denominators. Add the denominators. And obviously there's a ton more stuff we could do. I mean, we could add A over, yeah.
For the first one, is it supposed to be A times B equals CD or BC?
Doesn't matter.
Okay. So it doesn't affect the other ones?
No. Because remember, this is commutative property, so you can actually flip this at will. This could have been D times A equals B times C. And a lot of times I'll flip it depending on which one is my x value. So if I have x down here and a 2 up here, I'll make it 2x. But if x is over here and 2 is here, I'll still make it 2x instead of x times 2. Just because we know it's commutative, it doesn't matter which way we put it. Does that answer your question of sorts? If you're absolutely appalled by the way it's written, you can always just change them all to either BCs or change them all to CDs if you want to. If it helps you at all. But it is commutative, so it's all the same. All right, questions on any one of those 4? Those are the 4 common ones. So once again, we have cross multiplication, we can switch our middle terms, which are our means. We can take the reciprocal of both fractions, which is just flipping it. And we can also add the denominator to the numerator, as long as you do it on both sides. Those are the key 4 ones that you need to know, especially for this homework. All right, the last rule I want to talk about says that if A equals B equals C equals, A over B equals C over D equals E over F equals so on and so on and so on, that's actually, then we can add all of our numerators and take it over all of our denominators, and it will remain the same fraction as A over B. So for example, let's see an example of this. If we had 1 over 2, which equals 2 over 4, which equals 3 over 6. Do we all agree that those 3 are equal? Do we agree that all 3 of those are equal?
Yes.
Okay, so I can write that. Then according to this, if I did 1 plus 2 plus 3 over 2 plus 4 plus 6, that should equal 1/2. Well, let's check it. So 1 plus 2 plus 3, that's going to be 6. 2 plus 4 plus 6 is going to equal 12. Sure enough, that does equal 1 over 2. So if I add all of my numerators in a proportion, and I add all of my denominators, it's still going to hold on to that same ratio. Everything's going to have the same ratio whether I add them all or if I just take each one individually. Because 3 over 6 is going to equal 1/2. 2 over 4 is going to equal 1/2. If I continue that pattern, they're all going to equal 1/2. Whether I add them all or whether I just take them separately, they're all going to preserve that 1/2 ratio. So these are the big things you need to know for the homework and what we're doing next. All right, the next part. Example, use proportions to solve these statements. So this first statement says, well, 5 times y. So what we're doing really is just taking that 5 times that y. So we must be doing our means extremes one, or our cross multiplication. So if I'm using 5 times y, then that's going to be the same thing as 2 times x. The other cross multiplication. Bless you. So this starting out phrase is just going to tell you which one to look at to see how to finish the other side. So our next one says x plus y over y. Well, we must be adding our denominator. I'm adding the denominator y to the numerator. To keep it balanced, yeah. Yeah, go ahead. Go ahead.
It's 5 plus 2 over
Yep.
2.
Yep, 5 plus 2 over 2, or just 7 over 2. So if you can simplify, simplify. I guess it would have made more sense if I simplified it below. It'll save me a little space and make it a little cleaner. So 7 over 2. All right, next one is x over 5. Sabrina, do you think you know what that one's going to equal?
I think it would be y over 2.
It'll be y over 2. It'll be y over 2 because we switched out our means. We're allowed to switch those. The y and the 5 replaced each other. All right, the last one says 2 over 5. Who knows what that one's going to equal? Lydia?
Y over x.
Y over x. Yep, it's our reciprocal property. Like sometimes the hardest one to remember is the adding of the denominators. It just looks a little weird. All right, your job now is to complete the next few statements. So everything that's in this box. So 3, 4, 5, 6, 7, 8. I skipped 9, 10, 11, and I skipped to 12, 13. Because those are straight from the book. All right, the first one, if a over 2 equals 2 over 3, then 3a equals, it equals 4. That was basically our cross multiplication, our means extremes theorem, because we have 3 times A, that would be 2 times 2 equals 4. All right, the next one says if C over D equals 4 over 7, then D over C equals what? Yeah, Robin.
7 over 4.
It's going to be 7 over 4. That was a reciprocal one. Number 5 says E over F equals 5 over 9. So E over 5 is going to equal, actually,
F over 9.
F over 9. So you're saying your means switch places? Yeah, you are. Yep. Because our means are these guys. Just like, maybe? I don't know. I just know the answer. Don't ask me questions. Yeah, we're swapping our means where F and our 5 actually switch places. All right, next one says G over H equals J over 8. Then J over G is going to equal, J over G is going to equal. Did anyone get this one? Yeah.
Oh,
Yeah, sorry.
8 over H.
8 over H. Yep, that's what I got. And let's go through how I got that really quick, because it's always nice to, let's say you're on the test and you forget how things swap places. This is how I always do these if I get stuck. If I'm just like, which order they go in. I'm going to do cross multiplication to get me G8. So this is good for the complicated ones. Equals, let's just go HJ. So if you look over here, J is on top. So I must have moved my G over here. Which means to get the H over, I have to move it over here, so it's going to put it on the bottom. This is a really good thing to have drawn, and you should probably put it in your notes and try to use it. Because you know what's going to happen? We're not going to talk about this for a while, and then all of a sudden it's going to be on the test, and you're going to forget how to organize where the 8 and the H go. So this is a very quick way just to know where your values go. Just cross multiply and just see how they form this first thing. It's going to help you form this next thing. I promise you some people are going to get these wrong on the test. It happened last year. A lot of people would have H over 8 because we just don't cover it as much. Yeah?
What? Well, like, do we ever have to say, like, what method we use?
No. So even for number 5, you could have underneath number 5, you could have did your cross multiplication and said, well, E times 9 equals F times 5. 5 goes under E. So that must mean 9 goes under F. I don't even have to remember that the means can switch out. I can just show this, and I know it's correct. All right? It kind of alleviates that guesswork where you think you're guessing, is it on top, is it on bottom? Yeah.
Can I do 7?
Sure.
What's 5? It equals 2 plus 3 over 3.
Mm-hmm.
That's simplified down to 5 over 3.
Yep, perfect. So that's where we add our denominator. Our next one says N equals, NP equals QR equals 7 over 9. Then N plus Q plus 7 over P plus R plus 9 is going to equal, yeah. Oh, sorry, I just got you. Someone else. Yeah.
NP.
Simplified further. We can actually simplify it further. We can go further. I agree. I agree that this equals N over P, but there's a more simplified answer. Sabrina?
Would it be like reciprocal?
Not reciprocal. We're going the wrong direction with it. Evan?
Is it, wait, no, no. Is it gonna be a number?
It's going to be a number. We can actually put a number to it. Stephen?
1 over 1.
It won't be 1 over 1. Jacob?
7 over 1.
It's going to be 7 over 9 is going to be the most simplified form of it. So, Lee, I 100% agree. It equals N over P. And if that was if all this were letters, I would just say it equals N over P. But if we follow this down, N over P actually equals 7 over 9. So this is probably the most simplified because I'm actually putting numbers to it. Yes?
If all of them were letters, if we chose out of all 3 of them, wouldn't they all be right?
They'd all be right. That is such a great thing to point out. If all of these were letters, so if this was Q over R, this was Z over T, I don't know, you could have picked any one of these out and plugged it in there, and it is correct. All right, so you can pull any one of these out, and it's going to be equal to it. So we could have did the Q over the R. We could have done the N over the P. However, the most correct one would be the one that's numbers because it's already simplified I'm actually using numbers. Yeah.
Wait, sounds like all of them would be correct. Could you also say like n over r, or do they have to be together from the start?
They have to be together from the start. So at that point, you wouldn't want to do the reciprocals and stuff because they're already set up equal. So what Stephen's asking is, can you do this means extremes thing now? You'd have to do it first because then you would have to have n plus p plus 9 because you'd have to do them to all of them first.
Okay.
All right, number 12, 4 over y equals 7 over 9. Who wants to just give me what y equals, and then I'll fill in the rest, Akshay?
Oh, just y? Oh,
Yep.
5 and 1, 7. Or 36 over 7.
36 over 7. I'm going to use 36 over 7. I love fractions. I love them because I don't need my calculator. I can just write it, and it's correct. Okay, so let's see how that happens. So basically you do cross multiplication. So we can have, I'm just going to put the y on the side, so I'll do 7y times my 4 times 9. Well, 4 times 9 is actually 37. I guess I'll just leave it as 4 times 9, which is 37. So this should have been 36. So we have 36 divided by 7. All right, the last one is probably the trickiest one. Who thinks they got the last one? Robert. Oh, well, I just asked you a question. You can't ask another question.
No,
Okay,
like,
yeah.
About the problem.
Yeah.
So it says b equals t and a equals x, and then a equals x and b equals p.
Mm-hmm.
Is like the t and the p supposed to be different, or that's just a mistake?
It is not a mistake.
Okay.
It is not a mistake. It leads us to something. Yeah.
I'm right, but is it? I got tx equals px.
Close. Akshay, you want to take a guess at what I'm trying to go in? It's kind of an obscure question. I wouldn't ask this on a test. Yeah. T equals P. Yeah. I was looking for T equals P. So my setup was correct. So if I did this setup down here, so let's go below it. So if I would do the reciprocal of just this, if I just did the reciprocal of just that, I would have A over B equals X over T. Well, nothing changed except for this T and this P. And so that T has to be that P. They have to be the same value. All right, the rest is your homework. It does get a little complicated. You have to do some factoring on the backhand side. That's why the 3 problems have lots of space for you to work on. Take your time, check your answers. I'm also going to answer questions right now from 7.1. 7.1, what questions do we have, Lydia? Sure. So 34, that was a tough one. So 34. So 34 says, a basketball player has made 24 points out of 30 free throws. She hopes to make all of the next free throws until her free throw percentage is 85% or better. How many consecutive free throws will she have to make? So the first thing we're looking at is she started off with 24 out of 30, correct?
Yes.
So we're having 24 out of 30. So 24 is what she made. 30 is basically how many attempts she has. Well, she said she's going to continue to hopefully make her free throws, right? She's going to keep sinking them because somehow she can magically say that I'm going to make the next however many I need to. So she's going to keep shooting and she's going to keep making them. So I'm going to change this formula a little bit. So she's going to keep taking shots, right? If she takes 1 shot, she'll take 31 shots. If she takes 2 shots, it'll be 32 shots. But she's saying every time that she shoots, she's going to make it. So this X is also going to affect my made column. So every shot that she shoots, she's going to make it. So both of these will go up at the same rate. Does that make sense why I'm adding X to both the numerator and the denominator? Are we all okay with that? All right. So this is our increase. Well, let me go back to the question because I already forgot what she was shooting for. So she's shooting she's going to keep making this basket until she gets 85% completion. Well, the way we're going to write that as a ratio is I'm going to say I'm going to keep doing this until I have 85 out of 100. In other words, I'm shooting this till I get 85%. Because to get percentages, we always take how many we made divided by our total shots. I want it to equal 85%. Well, as a ratio, 85% is 85 out of 100. It is 85 out of 100. So all we need to do now is just do our cross multiplication. Where that goes there, that goes there. Which is going to result in, I just put 100 times 24 plus x equals 85 times 30 plus x. I'm going to let you do the math on your own, but you should come up with x equals 10. So that means she needs to take and make 10 more shots in order for it to be about 85%. Okay? Any questions on that one? That's probably the toughest one. Yeah. Yeah. Do you have any questions on the homework, though? No? You got it all done? No, you don't have? Okay, then maybe you should stick around, because questions can help you answer it. Yeah. Does anyone have questions on this one, I guess? Okay, yeah.
This one is like the one I did was like, I did 24 out of 30 times 85 times 100. I don't understand why that wouldn't work.
Because you did what now?
I just, like, I didn't add the x's or anything. I just did 24 over 30 times 85 over 100. And
So what you are saying, if you set it up that way, so you did this, you are saying that these ratios are equal to each other. You're saying if you plug in your calculator right now and you do 24 divided by 30, it's going to be the same value as 85 over 100. This is already assuming that she shot 85%. Type 24 over 30 in your calculator. And tell me what it comes out to.
0.8.
0.8. So right now she's actually, this is the only way you could write this proportion. Is 24 divided by 30 equals 80%. She wants to keep shooting until she gets to 85, so you have to add x's in here to balance it. Okay? Other questions? Yeah, Stephen.
Number 19.
Number 19. That must be on the back side. All right, number 19. Mine's a little different than yours. Number 19 is you actually have to factor it. Which I did actually factor it, so I'm going to take a picture of it because it is on the answer key as well. Did you have a question on how I factored it, or?
Yeah.
Oh, okay. So let me take a picture of it, and you can ask your question. All right, so here is 19. What question did you have specifically, I guess?
Wait, I got the wrong numbers.
Oh, okay. Okay. So I showed one of them. I showed how to factor 3x squared plus 2x minus 8. You probably had to do this on a separate sheet of paper because there wasn't enough room to do all of this factoring. I just factored the bottom one. I was leaving you in charge of this. Well, what I would do is I'd factor out a 3 out of everything out of that top one. Yes?
Oh, for number 19 I got 0?
It is not 0. That is the correct answer.
Oh, I don't understand, like, how, because I factored out all the, what I did was I factored out.
First of all, a fraction can't turn to 0 unless there's 0 on the top.
Oh.
There is no zeros on the top. So I factored this top one to being 3 times x plus 2 times x minus 4. The bottom one's going to factor down to 3x minus 4, x plus 2, which I did all of the work for you on how to do it. And the only thing that cancels out is the x plus 2 and the x plus 2. It is the only thing that factors out. You can't go any further than this. But this is the step-by-step guide. It is online. It's on the answer key, step-by-step on how to factor. If you're struggling on factoring, you need to come see me. Or you need to practice it on your own, because that's from Algebra 1. I'm not going to spend entire classes on factoring. We just don't have time. Other questions? You just had the wrong numbers then?
Yeah.
Okay. Try it again with the right ones. Other questions? Yeah.
Number 14?
Number 14. Number 14, we were supposed to do 2c minus 2d plus over 2 plus. What particular question do you have, I guess?
Kind of like because when I had 0 for number 19 and I also have 0 for number 14, so I'm kind of like assuming that may be incorrect.
Did you check the answer key, I guess?
I did, but not for these on the below.
Oh, okay. Okay, so for number 14, you can't do anything because nothing's being multiplied. So what you're going to do is you're going to factor a 2 out of the top one, and you'll factor a 2 out of the bottom one to get 2 times c minus d over 2 times c plus d, and the 2's will actually cancel out. In order to cancel out, you need to have a string of multiplications.
Oh.
Other questions? Okay, then work on your homework. I'm going to check this homework, 7.1. I'll check it tomorrow because I forgot to remind you that it was due today. So if you don't have it done, I guess you have a grace period. Get it done tomorrow. Check your answers. Like I said, we just don't have time to talk about this stuff too much because that was a whole topic in Algebra 1. We need to move on, and I have to just assume you know how to do it. If not, you got to come see me.